Good morning, students. Good morning, all. Let me share the screen. Good morning, all of you. Okay, so let me start the session. Guys, I think in the previous class, we have started a new module on direct and bending stresses. Okay, so the direct and bending stresses are very important in many applications. Why? Because, one second. The students are joining now. Yeah, just wait for a couple of minutes. So let us admit everyone. So by that we can start the session. Good morning all. Okay, let me continue, Amma. So by that, because we have very short time. Okay, yeah. So let me revise the things what we discussed in the previous class. Okay, so based on that, we will continue the thing. So in the previous class, we have discussed about what is the direct stress and what is bending stress. In the real applications, if you see the structural elements, okay, the structural elements may not be subjected only an axial load. Okay, it will be subjected to even the bending loads, okay, or other kind of eccentrical loads which makes member to bend. Okay, so basically axial load is a one, so which makes member to compress, especially in a column, right? But the same column, when it is subjected to an eccentrical load, okay, what happens? Instead of because of this eccentrical load, your column may have a direct stress along with the bending stress also. Okay, so that we have supposed to be study in this direct and bending stresses. Okay, so here eccentrical load in the sense, so the load which is acting on the cross section of the column bit away from the center of gravity of the section. Okay, so that creates member to have an eccentrical load, which member will have an eccentrical bending stresses. Okay, so that is how column is a structural element. In the real applications, practically it may not be possible to have an axial load alone. Okay, so you have to analyze, or you have to design your column not only for an axial load, it has to be designed for the eccentrical load also. Okay, so in that sense, this module is very, very important. Okay, so in the previous class, we have discussed what is the effect of axial and eccentrical load on the column, right? So here, let's see the left picture. You can see the column which is subjected to axial load. Axial load in the sense direct load. Direct load and the load which is passing through the center of gravity of the section alone. So if you see the left hand side picture, the center of gravity of the load is passing through the center of the section, so which have stresses uniform throughout the cross section. Okay, whatever the stress at the left hand side of the edge of the column will be same even on the right hand side of the edge of the column. Okay, so that means stresses will be same. So when the load is passing through the center of gravity of the section, how to calculate the direct stress? Direct stress is equal to resisting load towards the cross section area of the member. Okay, that's it. That is how you can able to calculate the direct stress. Okay, coming to the same column, when it is subjected to load which is not through its center, and the load which is making some eccentricity from the center of gravity of the section. So this load makes member to have an eccentrical load. Okay, what happens due to this eccentrical load? Here two types of stresses will develop. One is a direct stress. Why again direct stress is coming into picture? Why? Because in any structural elements, when a member is subjected to load, that member should always pass through its center. Okay, one, it should always pass. Okay, so this P load should pass. Finally, it should pass through the center of gravity of the section. That's why there will be direct stress. Automatically, it will develop. Along with the direct stress, there will be bending stress also will develop. Why? Because this is not a direct load. This is a eccentrical load. This eccentrical loads makes your member to have a bending stresses. Okay. If you see the bending stress of this member, this is the bending stress diagram, right? This bending stress diagram represents the stresses on either side or on either edges of the column. Okay, so if you see at this side, the stress will be like this, on this side the stresses will be like this. So this is the bending stress and this is the direct stress. Okay, these two will happen when the member is subjected to an eccentrical load. If you see the resultant stress, what do you mean resultant stress? Resultant stress can also be called as a combined stress. Okay, so this is very, very important. Why? Because your column is not just subjected to direct load, it is also subjected to bending stress. Kabatti, the combined stresses will be like this. So that means on the left hand side your stress will be less, on the right hand side of the column your stresses will be more. Okay, so this is the direct stress minus bending stress, and this is direct stress plus bending stress. Why here the stress is more? Why? Because your load is acting to the right hand side of the column edge. That is the reason why the stresses will be more on this edge matter. Okay, so that's how the resultant stress is supposed to be considered. These stress diagrams are very, very important. Okay, even if you want to explain to someone what is the direct stress and what is bending stress, with this special example, you can able to explain them it clearly. What is direct, what is bending, and what is resultant stress. How to calculate the bending stress? You all know the pure bending equation, which is M by I is equal to sigma by Y is equal to E by R. Okay, from that pure bending equation or pure bending stresses, okay, so I think you can able to calculate the pure bending equation easily, which is M by Z. What is Z? Z is a section modulus. Okay, I will try to explain you in the next coming pictures. Okay, right. So I think till that point we have discussed in the previous class. So next continue. So when short column is subjected to an axial compression force, only direct stress is going to be produced. What is the difference between short column and long column? Short column, in the sense, the height of the column will be very less. When the member is having very less height, what happens? That member will be subjected to only compression. Okay. Okay. So let me explain you in a pictorial representation. Yeah. So basically there are two columns. One is a short column, other one is a long column. Okay, short column in the sense the height of the column will be less. Okay, long column means this. Okay, both are columns. The difference here is the dimension. Okay, so here with respect to height, okay, so with respect to width, the height of the column is less. With respect to width, the height of the column is long. Okay, so here there will be only one possible failure, that is compression. Why? Because short column, I mean basically this is the compression member. Due to the compression force, short column members will be subjected to only compression. But here, as the column is very long, what happens? You may not able to transfer the load exactly to the center of the section. This long columns, instead of compression, long columns may there is a possibility of a long columns to buckle also. Okay, buckling. So buckling will happen only when load is not axial. Okay, when the load is not axial, there is a possibility of buckling failure. Okay, there is a possibility of buckling failure. And when the load is not axial, ante this load is creating some eccentricity. That eccentricity making your column to buckle. Okay, so that is the reason why long columns will always buckle. It is just because of having an unknown eccentrical distance from the center of gravity of the section. So that is the reason why. So here in short columns there will be only direct stress, which is load by area, but in the long columns there will be direct stress plus bending stress, okay, which is load by area, which is m by z. Okay, ఈ రెండు ఉంటాయి, అర్థమవుతుందా? In the long columns. Let us take a best example of your broomstick, చీపురు పుల్ల. ఓకే, ఒక పెద్ద లాంగ్ broomstick తీసుకోండమ్మా. Try to press the stick on from both ends. నుంచి స్టిక్ ని ప్రెస్ చేయండి. ఏమవుతుంది చెప్పండి? that stick will try to bend. Why? Sir, అదేం సార్, స్టిక్ నేను రెండు కంప్రెషన్ ఫోర్స్ అప్లై చేస్తున్నాను, అప్పుడు స్టిక్ క్రష్ అయిపోవాలి కదా. Why your stick is bending? Because even your hand may not able to transfer load through the center of the stick. అది మీరు ట్రాన్స్ఫర్ చేయలేకపోతున్నారు. Okay, so there is some eccentricity is developing in the broomstick. Because of that your broomstick is subjected to bending. Okay, అదే మీరు ప్రాపర్ గా ఎగ్జాక్ట్ గా సెంటర్ లోనే మీరు లోడ్ అప్లై చేయగలిగితే డెఫినెట్లీ యువర్ broomstick will subjected to crush instead of bending. Okay, so that is the reason why you have to know this important. Short columns will always crush, long columns will always buckle. అర్థమవుతుందమ్మా? Right, so that is the reason why. So the long columns will have both direct stress and bending stress. Okay, so that is what we are going to study here. Okay, see, when short column is subjected to axial compression force, only direct stress is produced in the column, so which is load by area. Eccentrical load produces both direct stress and bending stress in column, where it will be happen in the long columns. Okay, so where the direct stress will happen, which is load by area, and bending stress also happens, which is m by z. Okay, what is z? Section modulus, which is I by y. Okay, so that is how this can be written. Clear? Andarku ardhamaindamma? Right, next see the next picture. Maximum and minimum stresses. How to calculate the maximum and minimum stresses in a column? When a column is subjected to eccentrical load, the edge of the column towards the eccentricity will be subjected to maximum stress, and the opposite edge will be subjected to minimum stress. Avuna? So let's see the same picture. Ikkada chudandi. So when let us take the column which is subjected to eccentrical load. Due to this eccentrical load, is the overall resultant stresses are same? No. Ekkadaithe ఏ edge of the column లో అయితే లోడ్ యాక్ట్ అవుతుందో there is a maximum resultant stress. On the other edge there will the minimum resultant stress. Avuna? Then how to calculate this maximum and minimum stresses? When the column is subject to eccentrical load, how the maximum stress will be acted at the column, okay, and how the minimum stresses will be acted at the column. How to calculate this maximum minimum stresses anedi manam chuddam. Okay, so how you got this anedi we will try to explain it clearly here. Okay. Yeah. Maximum and minimum stresses in columns. Very, very important. Okay. Right. So what? Sorry. Maximum stress ante enti, which is a resultant stress load by area plus bending stress. So this is the direct stress and this is the bending stress. What is the minimum stress? Load by area minus bending stress. Okay, Nama? Right. Load by area plus. Okay. M by Z ni ela raichamma? M ante enti? Load into eccentrical distance. Okay. This is the load and this is the eccentrical distance. Okay, right? So P into E is nothing but moment. So here what is M? M is equal to P into E, load into eccentrical distance. Okay, by what is Z? Z and ఏంటమ్మా? I by Y కదా? Z is equal to I by Y, right? So how this can be written as, let us take a cross section which is having the same dimension of B by B. Okay, then what happens to Z? Z ఏమవుతుంది? B cube by 12 by B by 2. What is Z? What is Z? B cube by 6. Correct na? Right. Z ne em rayachu ikkada? B cube by 6. Right? చూడండి, జాగ్రత్తగా చూడండి. P by A plus 6 PE by B cube. Right? P by A plus 6 PE by, what is B cube, amma? B cube can be written as B square into B, right? P by A plus 6 PE by, what is B square? What is B square?
Area, sir.
Very good. Area into B. P by A ni common తీసుకునండి బయటికి. P by A of 1 plus 6 E by B. Very, very, very important, this formula, right? To calculate the maximum stresses acting in a column, okay, which is subjected to both direct and bending stress. అర్థమవుతుందా? In the same way, can you tell me what is this? ఇదేమవుతుంది చెప్పండి? P by A of 1 minus 6E by 2. Okay, this is the minimum stress acts in the column, right, at one edge, and this is the maximum stress which is acts at the column in the other edge, right? So ఇదే నేను ఇక్కడ మీకు చూపిస్తాను. Yeah. So maximum stress is equal to direct stress plus bending stress, which is this. Okay, so P by A plus M by Z. ఎలా వచ్చిందమ్మా ఇది ఈ ఫామ్ లోకి? ఇప్పుడు నేను ఏదైతే క్యాలిక్యులేట్ చేశానో, in that way you can achieve the formula of P by A of 1 plus 6E by B. Okay, and the minimum stress is like this. So you have to remember these two formulas, very, very important to calculate the maximum and minimum stresses in the column when it is subjected to an eccentrical load. అర్థమవుతుందమ్మా? Clear? In this very important parameter. Guys, sorry, there is some guys, I'm sorry, there is some internet connection problem, so that's why it went out. I think now it is clear, right?
Yes, sir.
Yeah. Okay. So let me share this. Okay, right. Yeah. So this is how we are going to calculate the maximum and minimum stresses in the column. Okay, right? Okay. So in this, please see it clearly. Sigma naught is the direct stress. Sigma B is the bending stress. M is the moment. E is the eccentrical distance. Okay. Z is the section modulus. Okay. And I is the moment of inertia, and Y is the distance from the extreme fiber from the center of gravity of the column. Okay. Right. Now this picture is very, very important. This is called the stress distribution in column. Very, very, very important. And even I have given a few assignment questions to you. In that, one assignment question is on draw the stress distribution diagram of the column. Okay, so this is very, very important. See, in this diagram, it is clearly showing stress distribution in column as the load moves from center of column to the edge of the column. Okay, so when the load moves from center of the column to the edge of the column, how the stress will vary, how the stress distribution varies from minimum to maximum anedi this diagram will show you. Okay, so please try to understand it clearly. In the first picture, load is passing through the center of gravity of the section. That means there is only direct stress. So on both edges of the column, your stresses is same. Okay, that's why the diagram is something like a rectangle. Now please try to move your load bit far away from the center of gravity of the section with some eccentricity. Okay, so then stress diagram will vary like this, as like a trapezoid laga vary avutundi. Okay, so at left hand side, your resultant stress will be minimum, and the right hand side your stress will be maximum. Okay, and inka move cheyandi, move your load far away from the center of gravity of the section. అప్పుడేమవుతుంది, your stress distribution will vary from trapezoidal to triangle. Okay, so where your stress at edge of the column A will 0 and the maximum stress will be at B anamata. Okay, and inka move cheyandi. Okay, so don't mind guys, actually these 4 pictures are different. Okay, second picture entante it is just far away from the center. Third picture is still more. Fourth picture is almost edge of the column anamata. Okay, so in the last, if you still move your load from the center of gravity of the section where your eccentricity is more, what happens at the time, your stresses will reverse anamata. This is called reverse law of stresses under. Okay, what do you mean reverse law of stresses? Your stresses will reverse, one is negative and other one will become positive. Okay, understand? So this happens when your load is moved all way from the center of gravity of the section. Okay, do you think this is recommendable? Fourth one, is the fourth is recommendable? No. So your stresses should not get a reverse law of stresses anamata. Okay, so never your column should have a reverse law of stresses. Understand? So the reverse law of stresses jarigindi ante, so definitely this is the biggest failure anamata. Okay, so here reverse law of stresses happens. Okay, చూడండి, reverse law of stresses అంటే negative stress, positive stress. ఇక్కడ only positive, ఇక్కడ only positive, ఇక్కడ only positive. అంటే the possibilities which are acceptable in the real applications are only these 3. Okay, so rest of they are not at all acceptable. Why? Because the reverse law of stresses will damage your structure more. Understand? So that is the reason why you have to see your eccentrical load should not be more away from the center of gravity of the section. It is to be seen by the designer. Okay, as an engineer, as a designer, it is your responsibility to see whether your eccentrical distance is within the limit or not. Okay, if it is crossing the limit, definitely your column or your structure is under problem. Okay, that you have to understand it carefully from this stress distribution diagrams. Okay, now question comes, sir, how to know whether the eccentrical distance of the column is more, which creating reversal of stresses అనేది నాకు ఎలా తెలుస్తుంది? How would I know the eccentrical distance should be this much, then only your column will be safe అనేది ఎలా తెలుస్తుంది? So now we are going to discuss that only. Okay, how to calculate the eccentrical distance of the structural elements without falling under reversal of stresses. Okay, so that we are able to know it now, right? Once again, let me rub it. Okay, yeah. So now here, limit of eccentricity. So the maximum distance of load. What is the limit of eccentricity? Till now we have gone through only what is direct stress, what is bending stress, what is direct load, and what is eccentrical load. Okay, so before this slide I just have shown you the stress distribution diagram in the column. Okay, so in this the stress distributions are varying with respect to the eccentrical distance. When more eccentrical distance, there will be reversal of stresses develops. So now point is you have to limit the eccentrical distance anamata. Ante which eccentrical distance is safe to the column. Beyond that eccentrical distance, definitely your column will be subjected to reversal of stresses. Then what should be the limit of eccentricity of a column to have a safe direct and bending stresses? Okay, so adi enta a limit anedi we are going to see it now. The maximum distance of load from the center of column such that if load acts within this distance, there is no tension in the column. Ardhamavutunda? So when the column is subjected to eccentrical load up to this distance, up to this limit, okay, so there is no tension in the column, right? If it is crossing that limit, what happens? Then there is a possibility of tension in the column. When the tension occurs in the column, then the reversal of stresses also will happen. Ippudu chudandi meeru. So this is one signature, one sign. Let us take it as positive, positive, positive. Ikkada positive, negative ante rendu reversal of stresses jarigindi. Ante so here I am treating negative as tension, positive as compression amma. Okay, so this positive indicates only under compression. Positive indicates only compression. Positive indicates only compression. Positive indicates only compression. Negative indicates tension ikkada. Okay, so this is how the sign convention was made, right? So to avoid this tension, what I have to do? I should not move the load more from the center of the column. So there should be some limit. That limit is called a limit of eccentricity. Very, very, very important heading ఇది. Okay, so చాలా మంది మిమ్మల్ని అడుగుతారు what do you mean limit of eccentricity అని. So you have to tell it clearly, the maximum distance of the load from the center of column such that if load acts within the distance, there is no tension in the column. If it is crossing the distance from the center of the column, then the tension exists. That tension will create the reversal of stresses in the column అని మీరు చెప్పగలగాలి. Okay, so the maximum distance is called the limit of eccentricity. Okay, within the limit anamata. Beyond that limit, tension will develop. When tension develops, reversal of stresses takes place. Okay, so when load is acting within the limit, so there will be only positive sign. Positive ante em cheppanu nenu indaka compression. When load is acting at the point of limit ante direct ga center of gravity act అయింది అనుకోండి, అప్పుడు E minimum will be 0 కదా. When the load is acting beyond E limit అంటే beyond the limit of eccentricity, అప్పుడు ఏమవుతుంది? Negative sign will develop. Negative sign indicates that your member is under tension zone. Okay, so these three very important. Okay, లోడ్ ఎప్పుడైతే సెంటర్ లో ఉందో అప్పుడు ఆ స్ట్రెసెస్ అనేది ఉండదు. లోడ్ అనేది eccentrical distance within the limit unte, then there will be only a compression stresses develop. When the eccentrical distance is beyond the limit, then the tensile stresses will develop. Tensile stresses will create member to have a reversal of stresses. Okay, so these concepts are very important before proceeding into the problems, before proceeding into the concepts, how your real application structures are subjected to direct and bending stresses. I hope మీ అందరికి ఇప్పటి వరకు నేను చెప్పిన కాన్సెప్ట్ అర్థమైందని అనుకుంటున్నాను. Right now we are going to discuss what is that limit of eccentricity. Sir, how to ensure that the limit of eccentricity of a square column should be this much? What is the limit of eccentricity of a circular column of this much? Rectangular column ఇంత అని ఎలా తెలుస్తుంది సార్? How to finalize the limit of eccentricity? Because if you able to limit the eccentrical distance, then you can able to avoid the tension in the column. అది మనకి ఎలా తెలుస్తుంది అనేది we are going to discuss it now. Okay, let me show you the అందరికి అర్థమైందమ్మా ఇక్కడ వరకు? క్లియర్? Are you all understood what is direct and bending stresses? What is limit of eccentricity? What is stress distributions in the columns? Everything? Please respond.
Yes, sir.
Yes, very good. Now let's discuss which is very important. You can put it 3-4 star marks as per the GATE and competitive exams concern. Okay, right. Now, yeah. So now keep the heading, which is condition for no tension in the section. Condition for no tension in the section. Can you tell me what do you mean condition for no tension in the section? No tension ante entamma? ఈ లిమిట్ లో ఉన్నట్టే, అవునా? No tension means E is under limit. Okay, so now what are the conditions for no tension in the section? ఏంటి conditions ఏంటి? So let's see. The conditions are like this. So when it indicates your direct stress is less than the bending stress, stresses changes its sign, being partially tension load and partially compression across the sections. Okay, so I think you already seen it clearly. This is eccentrical distance. Okay, so now the condition is like this. Your direct stress should always be greater than or equal to bending stress. Okay, so which is M by Z. Okay, and then your bending stress is M by Z. What is sigma dm? Direct stress ante enti? Load by area should always be greater than or equal to, right? So let us take this as a square section. Okay, which is having a depth of D, square section, depth of D. Okay, and this is a D by 2, right? What is sigma BM? Load into distance, right, by Z. అవునా? P by A greater than or equal. ఇది. So this is what M by Z. M అంటే ఏంటి? Load into distance by Z, right? P into E into what is Z? Z ఏంటమ్మా ఇక్కడ? I by Y. What is Y? What is Y ఇక్కడ? d by 2, right? So this can be written as, z can be written as I by d by 2 kada, p into e into d by 2 times of I, right, sir? Can I write this in this form, Amma? P into e into d by 2 times of I. Z is equal to I by d by 2 kada, అందుకే దీన్ని 2I d by 2I అని రాశాను. Okay, right. Now you all know what is section modulus. Can anyone tell me what is the formula of a radius of gyration? Radius of gyration. What is the formula of a radius of gyration? ఎలా అమ్మ మర్చిపోతే k is equal to root of I by a. Okay, what is k square? K square name రాయొచ్చు I by a, right? What is I? K square into a. Okay, radius of gyration. I ఏమని రాయొచ్చు? I is equal to k square into a అని రాయొచ్చు, అవునా? p by a, p into e into d by 2 times of a k square. Okay, so finally from this, what is eccentricity? E is nothing but e is less than or equal to 2k square by d. Why? Because p will get cancelled. So finally e is this. Okay, very important. See here, what is d here? D is equal to depth of section. What is k here? Radius of gyration. Ante from this, what you understood, amma? From this statement, from this relation, what you all understood, that means for any section, okay, to have no tension in that section. Ante no tension ante eppudu undadu tension? When the eccentricity is within the limit. Antena? When the eccentricity is within the limit, there is no tension. Okay, so ante eccentricity enta distance maintain cheyali from the center of the section? Your e should not be less, your e should always be less than or equal to 2k square by d undali unte, so then this will be under no tension. అర్థమైందా అందరికి? Okay, so this creates limit of eccentricity. Okay nama? So very important, star mark రాయండి. No tension in the section, the eccentricity must not exceed in the 2k square by d, and it should always be less than under any section. A section aina తీసుకోండి, your eccentrical distance should be less than or equal to 2k square by d times undali. Okay, with this formula we are going to write what are the eccentrical distances to be maintained for different sections like circular section, hollow circular section, square section, hollow square section. వీటన్నిటికీ we will try to write down what should be the eccentrical distance with respect to this formula. E is less than or equal to 2k square by d. D అనేది the depth of the section, k అనేది radius of gyration of that particular section. అర్థమవుతుందమ్మా? వెరీ ఇంపార్టెంట్ అమ్మా కాంపిటేటివ్ ఎగ్జామ్స్ కి ఇది. ఓకే, So ఇది బేస్ చేసుకొని now we will try to write down what is the eccentrical distance to be maintained for rectangular section to have no tension in the particular section. ఆ సెక్షన్ లో టెన్షన్ ఉండకూడదు అంటే మరి ఎంత ఎక్సెంట్రికల్ డిస్టెన్స్ మెయింటైన్ చేయాలి, ఎంత లిమిట్ ఆఫ్ ఎక్సెంట్రిసిటీ ఉండాలి ఆ పర్టికులర్ సెక్షన్ కి అనేది we will try to write down now. ఫస్ట్ సెక్షన్ ఓకే, డైరెక్ట్ గా నోట్ చేసుకోండమ్మా. ఫస్ట్ వన్ రెక్టాంగులర్ సెక్షన్. ఓకే, రెక్టాంగులర్ సెక్షన్ అంటే సో లెట్ us take a rectangular section. ఓకే, క్రాస్ సెక్షన్ అర్థమవుతుందా? దీంట్లో దిస్ ఈజ్ యువర్ ఎక్సెంట్రికల్ డిస్టెన్స్. ఎంతమ్మా ఈ డిస్టెన్స్? d/3 d/3. అర్థమవుతుందా? అంటే యువర్ E should be less than or equal to d/3 distance in a rectangular section అని అంటారు. ఓకేనమ్మా, క్లియర్ రైట్? దిస్ ఈస్ ద మీనింగ్. రెక్టాంగులర్ సెక్షన్ కి E అనేది ఇట్ షుడ్ బి లెస్ దాన్ ఆర్ ఈక్వల్ టు d/3 ఉండాలి. అంటే ఆర్ ఈక్వల్ టు కూడా ఉండొచ్చు, ఈక్వల్ టు d/3 ఉండవు. ఉంటేనే యువర్ రెక్టాంగులర్ సెక్షన్ విల్ నాట్ హ్యావ్ ఎనీ టెన్షన్, నో టెన్షన్ సెక్షన్ అవుతుంది. ఓకే, అంటే మీనింగ్ ఏంటి? లెట్ us టేక్ రెక్టాంగులర్ కాలమ్. This is your load, this E distance. ఓకే, ఈ E distance మీకు కనిపిస్తుందా? ఈ E distance ఎంత ఉండాలంట? ఈ E distance ఇది d/3 అయితే ఈ డిస్టెన్స్ ఎంతమ్మా? ఇదేనా ఈ డిస్టెన్స్ అని ఇక్కడ నేను చూపిస్తుంది? కరెక్టేనా? ఈ డిస్టెన్స్ ఏమే కదమ్మా? ఫ్రమ్ ద సెంటర్ టు పాయింట్, ఎండ్ పాయింట్, రైట్? వాట్ ఈస్ దిస్ డిస్టెన్స్ వెన్ ఇట్ ఈస్ d/3? ఇట్ ఈస్ d/6. ఓకే, సారీ ఇది d/6, d/3 కాదు, d/6. అంటే E షుడ్ బి d/6 distance of the load, okay, to with respect to load. Okay, overall d/3 అమ్మా. ఇక్కడ నుంచి ఇక్కడ వరకు d/3 and this half of the distance is d/6, right? So when you try to maintain eccentrical distance as d/6 from the point load, okay, P, then you can able to achieve no tension in the rectangular section. Okay, if it is crossing d/6, then there will be a possibility of reversal of stresses in the rectangular cross sectional column అని అర్థం. అందరికి అర్థమైందా? ఇది క్లియర్? అమ్మా, వెరీ ఇంపార్టెంట్ దిస్ ఫార్ములా. క్లియర్? ఇది ఎలా వచ్చింది సార్? హౌ యూ గాట్ దిస్ d/3 అంటే సేమ్ ఇందాక we wrote one formula, right? E less than or equal to 2k²/d. With respect to that only we have calculated this thing. Okay, if you want, let me show you for the rectangular section how we calculated for this. So Iyy is equal to entama. What is the moment of inertia of the rectangular section? bd³/12. Okay, let us take this as d. ఈ ఒక్కదానికి చూపిస్తాను. I will try to show you for rectangular section how you got E as d/6. Okay, how you got this distance as d/3. Okay, I. What is the area? B into D, right? Iyy ని ఏమని రాయొచ్చమ్మా? A into k²yy రాయొచ్చా? Right? Because you all know moment of inertia formula enti I is equal to A into y². Y is nothing but gyration distance. Okay, k square yy is equal to Iyy by a. What is Iy by a? BD cube by 12 into what is a? BD. What is this? D cube by 12. Right? K square yy is equal to what? D cube by 12. Okay. Right? Now, what is the earlier equation which we have derived from no tension point? No tension point in మనం derive చేసిన condition ఏంటి? E should always be less than or equal to 2k square by d. ఈ ఫార్ములా ఎప్పుడు మర్చిపోకూడదమ్మా. Okay, E should always be less than or equal to 2k square by d. Okay, in this I know what is the value of k square of the rectangular section. K square of the rectangular section and the d cube by 12. Substitute this in this formula. Okay, E less than or equal to 2 k square d cube by 12 substitute చేయండమ్మా. ఏమవుతుంది? d square by d into 12. అవునా? Finally what it become? d by 6. Right? Clear? Ante your E should not be less than d by, sorry, should always be less than or equal to d by 6. Ante E can be equal to d by 6. ఇదే కదా which I wrote here. E is equal to, చెప్పండి అమ్మా.
సార్ k square is equal to d cube by 12 కదా సార్?
ఏంటమ్మా? k square is equal to
d cube by 12.
అవునమ్మా, k square is equal to d cube by 12 కదా
సార్ ఇక్కడ e is equal to 2d square.
కాదమ్మా, k square is equal to d cube by 12. Substitute this k square in this formula. 2k square by d. ఒక d క్యాన్సిల్ అయిపోతుంది కదమ్మా. టూ ఇంటూ k స్క్వేర్ ఏంటి? d క్యూబ్ బై 12 by d. Right? Six times d square by 6.
Sir, k square equal to d square by 12, sir.
Sorry sir, k square is d square by 12 అమ్మా. సారీ ఇది d క్యూబ్ కాదు, ఇక్కడ ఆల్రెడీ d ఉంది కదా. రైట్ సారీ d స్క్వేర్ అమ్మా, ఇది d క్యూబ్ కాదు. ఓకే, d by 6 కరెక్ట్. d square by 12, it is not a d cube. నేను తప్పు రాశాను ఇక్కడ, d square, then it will become d by 6. okay, right? So understood, right? So ఇక్కడ చూడండి, one thing is based on the moment of inertia, based on the radius of gyration, you have achieved the value of the rectangular section of d square by 12. Substituting this value from the original equation, which is E should always be less than or equal to 2k square by d, we came to know that if you take any rectangular column, any rectangular cross-sectional column, it's stating that your eccentrical distance should not be less than d by 6. Okay, to achieve, to get no tension in the column. What happens if it is more than d by 6? Your column will have a tension also. If the column have tension, then the reverse law of stresses will develop. Reverse law of stresses develop avadam ante enti? There will be tension, there will be compression. Both compression and tension rendu vachestayi anamata. This always create a huge or massive failure in the column. Understand? So that is the reason why you have to know what is the limit, so what is the eccentrical limit of the different sections anamata. Okay, that we have to know. ఇదే విధంగా let me write what is the eccentrical distances of the other sections also. Okay, please try to note down them. Fast note chesandamma. We have only few minutes time. There is another lecture. Rectangular section ki E should always be less than or equal to d by 6. Okay na? Next, hollow rectangular section ki first general equation రాద్దాం. ఏ సెక్షన్ కైనా ఓకే ఫర్ ఎనీథింగ్ యువర్ E should always be less than or equal to ఏంటమ్మా 2k² d. ఇది మైండ్ లో పెట్టుకోండి. ఓకే, దీన్ని నో టెన్షన్ సెక్షన్ అంటారు. With this only we have derived for rectangular section for other sections. Now for a hollow rectangular section ki direct ga your diagonal అంటే మీ ఏరియా ఉంది కదా ఎంత ఏరియాలో ఉండాలి. ఓకే, just now I have drawn you kada, this is the center ante within this limit only your eccentrical distance should be maintained. In the same way for a hollow rectangular section it should be maintained as db cube minus db cube by 3b of minus idam. Okay, this is for vertical diagonal, right? In the same way for rhombus ki ela untundante for rhombus ఎందుకంటే రెక్టాంగులర్ రాంబస్ విల్ బి ఆల్మోస్ట్ సిమిలర్ కాబట్టి 3d ఆఫ్ bd minus small bd, right? Okay, for the next one, circular section E should always be less than or equal to d by 8. Okay, for a hollow circular section E is equal to d square plus small d square by 4d. Okay, so these four are very 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 important amma. Please try to remember. Okay, so same for a circular section aithe మీ సర్క్యులర్ సెక్షన్ ఈ లిమిట్ దాటి వెళ్ళకూడదు. ఓకే, సో దిస్ డిస్టెన్స్ ఈస్ d by 4. Okay, and the eccentrical distance is ఈ డిస్టెన్స్ ఎంత d by 8 దాటి వెళ్ళకూడదు. If it is not crossing this limit, then your column will have no tension anamata. Okay, so please try to remember this formula. For circular section d by 8, for rectangular section d by 6. Hollow rectangle ki aithe ee formulas tho manam this what is that eccentrical area ni manam measure cheyochu. Okay, what is the distance anedi. For hollow circular section ki your 2e should be d square plus small d square by 4 times of the capital D. Okay, so these are the very very important eccentrical distances, right? So hope afternoon I will take a class. Okay, based on my health status I will inform you, Amma. In that I will let you know what are the applications and we will try to solve problems on okay those applications, right? Okay, right. So please get ready for the next class. Okay, so I will meet you. Okay, right.